Okay, moving on from lecture 5, let's move to lecture 6, and let's see if we can get through decisions. So I'm going to push on this a little bit fast with the idea that maybe we can actually catch up. We've been dealing with things, right? And we introduced this max function, and max lets us give a sequence of values and pick out the biggest value there. So we can come in here and we can put in, come on. When I'm having problems cutting and pasting, that's a bad sign. Not enough. It's either too much coffee or not enough coffee. I haven't decided. All right, so we can come in here and we can do something like this, right? And we can paste in some code, right? And we're going to ask for Chris's height, and we're going to ask for Sandy's height. And then we can use our max function to determine who had the highest, or what the highest height was. You know, so in centimeters, and I suck at centimeters, we'll say 13 centimeters, because Chris is a little bit short. And Sandy, well, Sandy's a giant, 10,234 centimeters. And we can say that using just this code, using the things we've learned so far, we can say that 10,234 is bigger than 13, right? We have that, our max function, our min function, they allow us to do these types of calculations. But what they can't allow us to do is say, well, Sandy is taller than Chris, because all we can get is the larger number. We don't necessarily know, there's no annotations, you know, other than the variable names, which is only good inside the program, telling us whose height is bigger. So we can't put out to somebody else, to the user, well, Sandy at 10,234 centimeters is taller than Chris. So, so let me bring up my notes. Either that or I have to go back to the notes. Okay. So if we want to decide, we have to introduce this concept of an if statement. So this is similar code, but instead of just pulling out the greater value, right? What we do instead is we put in the values. We can do a comparison asking which one is taller, and then we can print out, if we wanted, we could print out the value as well. Or Sandy height, right? So now we can actually make a decision, and we can decide who actually is taller. And we can run this, and Chris can again be 13 centimeters. And Sandy can again be 10,234. And now we can come in and we can say Sandy is taller at 10, because Sandy has height 10,234. You know, or we could run it again, maybe, and this time maybe Chris grew, and Chris is now 10,235, and Sandy is still 10,234, and now we can say that Chris is taller. So we have the ability. Can I slightly zoom out my screen? Not really. Let's see, what do you... I can make the font bigger if that helps, maybe. Huh. I'll tell you what, I'll take a look at that for next time. I'm not sure that I can... It used to be easy. Anyway, okay. Wants me to word wrap or something. Ah, for up here. I will take a look at that for next time, but maybe I can move this over for now. How's that? It's just cut and pasted from the code, or from the what do you call it? The window. Okay, so Yeah, actually, if you want me to word wrap, then making the font bigger would make this even worse. So what we want to talk about today is we want to talk about Boolean logic and the way to make these types of decisions. So our programs so far have been this kind of straight line stuff, right? We have a calculation, we go through, we manipulate a string, we put out a value. And if we want to try it again with a different value, we just run the program again. Sometimes we even change, some assignments within the code. If we want to do branching, if we want to do conditionals, if we want to take different code paths depending upon the inputs or the results of our calculations, then we have to start getting into decisions, if statements, Booleans, etc. Booleans, by the way, are yet another type. We have had floats, ints, and strings so far. Booleans are the next type. The cool thing about Booleans is Booleans are great for lazy people. There are only two values, true and false. So what we want to do is we want to convert from values like, come all the way down, like 10,235 and 10,234, and we want to convert those values into Booleans. And the way we do that is with something called relational operators, right? Before I get too far ahead of myself, let me go back into this Boolean. So Boolean is a proper type. So as with any proper type, right, we can assign it to a variable and we can print it, right? And we should know that true, the string true, is not the same as true. Okay? So the string true, this true you see here is actually a value. It's the same as like a 7 or a 12, right? It's a value. So it's not a string. It's not the string whose value is that contains the characters for true. And the same with false. Okay, so these are actually, proper values. Oops. That is a mistake I make all the time. All right, so it's important to recognize that these are actually values. You can do algebra with them. A Boolean algebra is kind of the foundations of computer science. So let's start looking now at some of the things that we can use with them. We've been working with relational operators, less than, or equal to. I guess we've been working with over here. We've been working with greater than, right? This is a relational operator. And what this is doing is this is asking the question. It's asking the question, is Chris height greater than Sandy height? Okay? And if the answer to that is either going to be true or the answer to that is going to be false, our Boolean, two values, has to be one or the other. Right? It's either greater than it or it's not greater than it. If it's greater than it, right, the relation evaluates to true, and at that point we come down and execute this block. If it's not greater than it, this relation evaluates to false, and we come down and execute this second block after the else. All right? So let's look at some of these relational operators. I think for now I'll move this back over again. And, right, let's set up some values. We can set up x equals 17, y equals 15.1. And now hopefully this is directly from your sheet because I think I'm reading it from the sheet. Right? And now we can ask a couple questions about this. We have x and y. We can say, is the value in x, the 17, is that less than the value in y? And that's not true, right? Because 17 is greater than y. So that is not a true statement. It evaluates to false. And by the way, that would work if we did 17 less than 15.1 as well. So it doesn't have to be in a variable. It can be a literal. So with anything else, you can put values into variables, and then having put values in variables, they become synonymous with the value. Yes, we will talk about that in just a minute. about the equality case that we're kind of ignoring right now. We'll get to that. We can also ask the question, is x less than or equal to y? Right? Well, 17 is not less than 15.1, and it's not equal to 15.1. So that would also evaluate to false. And we can ask the question, is x less than or equal to 17? Well, x is equal to 17, so that should be true. And we can come through and continue on using these relational operators, y greater than x, right? All of these relational operators work, and they have pretty much the sense that you would expect them to be. If the value on the left is less than y, this is true. If the value on the left is greater than the value on the right, this is true. And then the equals just add the equality case, right? If x is greater than or equal to, or x is less than or equal to. The thing is that this works with numbers, and you can see that it works with both floats and ints, and mixing floats and ints, but it also works with strings. So we can say, what do we have? S1 through S4. So S1 is equal to art. S2 is equal to art. S3 is equal to music. And S4 should be equal to music, right? Lowercase. Now, the interesting thing about this is what less than actually means. And the lecture exercises for today will be due at midnight tomorrow, 59 p.m. on Friday. Okay, so now we can ask some questions, and we'll ask the obvious question. S1, which is art, we'll ask, is S1 less than S4, right? Is art, all in lowercase, less than music, all in lowercase? And that's true, and the reverse holds as well. Where we start getting into issues is when we start mixing case. So if we look at S1 and S2, right, they're the same except for the case of the first letter. Capital A is different than lowercase a. So if we ask something like, is S1 less than S2, that's false. And yes, it makes a lot of sense to compare strings. We do it all the time. If you want to alphabetize something, for example, you need to compare strings, which is the big example. The problem we're running into, though, is when you mix cases, art art with a capital A comes before art with a lowercase a. And in fact, if we look at S3, music with a uppercase M comes before art with a lowercase a. Okay? And this is based on this concept of what's called lexicographical order. Okay? This is the word. Lexicographic. And in previous semesters, I would tell you that this is absolutely going to be on your test. I would expect that this is going to be on your test because it's hard to talk about comparing strings without using the words lexicographic. What it basically means is the order that characters are in our ASCII table. And what the ASCII table is it's a list of all the characters that can be printed. Actually, there's another table with UTF-8 and UTF-16. But basically, in the ASCII table, on a good day, I would have had this up already. right? This is the order of all the characters. And not all the characters are printable, but when you're doing a comparison, what you're getting is you're getting, you know, the ASCII code for capital A is 65, so you're comparing 65 against lowercase a is 97, and 65 is less than 97, right? So it's alphabetic as long as you stay within the same case, but as soon as you get to the point of being outside of the same case, then uppercase comes before lowercase. A lot of the punctuation comes before anything. Numbers, the characters for numbers, the printable characters for numbers come before all of the letters. So this is what this is based on. That's why you kind of see these funky things when we're actually looking at comparisons between strings. Okay. We looked at less than, greater than equals, less than or equals. There's also equality. Are they the same? So S1, is that equal to S1? Right? Well, it should be, right? S1 is art. Is S1 equal to S2? No, S2 is the capital art. Is S1 not equal to S2? Right? So art with a lower a is not equal to art with an upper a. So these are the other symbols you need to know, the other relational operators. Equals means they have to be the same, including case. And not equals means they have to be different in at least one of the letters. In this case, it's the first letter. Okay? This double equals, you'll see me make this mistake all the time. Double equals is not the same as the equal sign. The equal sign is assignment, right? You can say W equals S1, and what that makes is W the same as S1. W equals S1 doesn't assign anything new to W, but it does the evaluation. Is W the same? All right. I'm going to skip the stop to let you do exercise 1. I will point out that the lecture exercises are here. They're due tomorrow evening at 11:59, so Friday evening, just before you go to bed, or just before you go out, or whatever you're going to do. They're due. The first two are just generate text files and tell us which one of these relations evaluate to true. Okay? Where am I? Okay. So now that we've talked about relationals, we can generate I would have to look up. There is a way to do it. I don't remember it off the top of my head. Somebody's asking in the chat whether there's a way to get Python to tell you the ASCII value, the ordinal value of an ASCII character. And ord, thank you. As soon as I said ordinal, it kind of made sense. And ord will tell you, like, ord of should tell us 97, right? That's what I told you it was going to be. All right, so